Hi all, this is lecture 25. We're in section 7.1 and we are verifying identities. Okay, so an identity is an equation which simplifies to exactly the same expression on both sides, right? So 1 equals 1, x equals x, x plus 2 equals x plus 2. As long as you have exactly the same thing on both sides, that's an identity. Okay, now here are three additional identities we have. We did some basic ones back when we learned definitions of trig functions, but here I have three more from you and I want to show you where they come from. So if I take a look at the unit circle, see if I can draw one for us that's not too crazy. I do my best. All right. Now, here's my unit circle. Here's my angle x. Here's my right triangle, okay? Now, the coordinate that sits right here, we know from the unit circle is cosine x, sine x. Now, the x coordinate here represents how far along the x-axis you go. So this distance here is the same as cosine x. The second coordinate is your y coordinate. So that's the height, right? If you were plotting the point 2, 3, you go to the right 2, up 3. So that means that this distance is sine x. And this is a unit circle, which means that the hypotenuse, or that radius, is always 1. So now if you use Pythagorean theorem here, Pythagorean theorem is what we use in right triangles, and that says square each of the legs. So my legs are the sine and the cosine. So if I square the sine and square the cosine and add them up, I'm going to get the hypotenuse squared, which is 1 squared, which is 1. And that's the first identity we have over there. Okay, so that's exactly where it comes from. Now, how do I get the other two? Well, we can get the other two by doing some algebra. So if you take that sine squared plus cosine squared equals 1, and you divide everything by cosine squared. So we're going to divide everything by cosine squared. And we use our basic identities. Then sine over cosine is tangent. So this one is tangent squared. The cosines will cancel out to get 1. And 1 over cosine is secant, and it is squared. So that's how we get our second one. And this time, if we redo the same thing but divide by sine squared, we'll get the other one. So if we have sine squared plus cosine squared equals 1, and this time we divide through by sine squared. Then these two sines will cancel out, and I will get 1. Cosine over sine is cotangent, and 1 over sine is cosecant, and everything is squared. Right? And those are exactly the three identities we have over here at the left, right? So that's where they come from. They're not just randomly pulled out of nowhere. Those are our three identities. Now these two, the tangent and the cotangent, not used that often, okay? Sometimes we'll use them in calculus depending on what trig function you're given. But for our purposes in verifying identities, 90% of the time you're going to use the sine squared plus cosine squared equals 1, okay? So we're going to focus a lot of our energy there. All right, so let's take a look at how we're going to verify these identities. So our objective here is to make both sides look exactly the same. And we can use any algebra, and we can use our basic identities. So we know that tangent is sine over cosine, cotangent is cosine over sine, secant is 1 over cosine, and cosecant is 1 over sine. So we can use those four, and we can use our sine squared plus cosine squared equals 1. So we can use any of those identities and any standard algebra techniques to make the two sides look the same. Typically, our strategy here is going to be convert everything to sines and cosines, and then do your algebra to simplify. So that means I'm going to take the secant and the tangent, and I'm going to convert them to sines and cosines. So secant is 1 over cosine. The cosine of x stays the same. The sine of x is going to stay. And tangent is sine x over cosine x. Okay, so now I've done the conversion. Now all I have are sines and cosines. But now I've got fractions. So I'm going to clear out my fractions. So I'm going to multiply this side over here by the denominators, which is cosine, and this one over here by the same. Right? right? And on the left, we're going to have to distribute because there are two terms there. So when you distribute, cosine times 1 over cosine is 1. Cosine times cosine is cosine squared. On the right-hand side, this cosine and this cosine cancel out because that's all one term. No addition, subtraction, so it's all one term. So I can cancel that. And then sine times sine is the sine squared. Okay, now this is almost the identity I have up there, but I want to put the sine and cosine on the same side. So I'm going to add the cosine squared to each side. And then I'll have 1 equals sine squared x plus cosine squared x. And then based on our identity above, this piece on the right is 1. So I get 1 equals 1, and now I've got my identity. So I've reduced it to where I have exactly the same thing on both sides. So that's our objective. Let's look at one more. Okay, so same kind of thing. I'm approaching this by looking at what are sines, what are trig functions that are not sines and cosines. So I've got a secant, a tangent, and a cotangent. So I'm going to switch those to sines and cosines. So secant is 1 over sine. Scratch that. Secant is 1 over cosine. There we go. And then we have sine x times tangent is sine x over cosine x. And cotangent is cosine x over sine x. Okay. Now what I'm going to do next is I'm going to go ahead and distribute because I've got something sitting out here. So I'm going to take this sine x and I'm going to distribute it to both terms. Okay. So I still have the 1 over cosine x on the left. On the right, when I multiply across. So that's going to give me a sine squared in the top and a cosine x on the bottom. When I distribute to the right term, the signs are ones on top, ones on bottom. Those will cancel, and I'll just get cosine x. So I distributed. Now I've got fractions, so now I want to clear my fractions. So I'm going to multiply both sides by the denominator, which is cosine x. Be aware that on the right I have two terms, so we're going to be distributing here. So on the left, they cancel, and I'm left with just 1. And on the right, when I distribute it to the sine squared over cosine, the cosines cancel, and I get sine squared. And cosine times cosine is cosine squared. And there's your identity again. So this right-hand side is equal to 1. And it's equal. Okay. So there's another version of verifying our identities. On to number 3. Now this one, take notice here, this one's already in all sines and cosines, so I don't have to convert anything. So next I'm just going to deal with the fractions. So let's go ahead and clear our fractions. Let's multiply both sides by both denominators. So that's going to be times cosine x on both sides and times 1 minus sine x on both sides. On the left, the 1 minus sine x cancels, and I get to cosine times cosine is cosine squared. On the right, the cosine x cancels, and we get 1 plus sine x times 1 minus sine x. Okay, so next we're going to FOIL that out. So we have cosine squared on the left, and then if I multiply this out, 1 times 1 is 1. The outside is negative sine x. The inside is positive sine x. And the last is negative sine squared x. Okay, now notice what happens. These two right here cancel out. Boom, boom. And I'm left with cosine squared equals 1 minus sine squared, which is a version of one of the identities we have up above, but let's make it look like that. So we're going to add the sine squared to both sides. That's going to give us sine squared x plus cosine squared x equals 1. And there's our identity. This side is equal to 1, and we get both sides equal. On to number 4. Hold on, I think this is the same one as the guided practice number 4. Secants and tangents squared. Nope, slightly different. All right, let's go for it. All right, so tangent squared minus secant quantity squared. So let's change our tangents and secants. So tangent is sine x over cosine x minus 1 over cosine x. Actually, this looks identical, but that's okay. We'll do it. The right-hand side, we're not changing. Must have forgot to change that one. This becomes sine x minus 1 all over cosine x squared equals 1 minus sine x, or 1 plus sine x. All right, now here's what I want to do. I'm going to do two things. I'm going to factor a negative out of this. So this one is just a tad different. Factor a negative out of that. So that's negative 1 times negative sine x plus 1. Square all of that. All over the cosine squared. So distribute that square. That gives me 1 minus sine x over 1 plus sine x. Then we are going to do two things. I'm going to square this part, and that just becomes a 1. So I'm going to switch the order of these two. It's addition, so the order doesn't matter. So 1 minus sine x squared, and negative 1 squared is 1. 1 times whatever is whatever. Now on the bottom, we're going to go over here and think for a second. We know that sine squared x plus cosine squared x equals 1. But I just want to solve for cosine so that I can replace the cosine. So if I subtract sine squared from both sides, I get the cosine of squared of x is 1 minus sine squared x. So that's just a different version of our current identity. And that's what I'm going to use to replace over here. So this is 1 minus sine squared x. And this is 1 minus sine x over 1 plus sine x. Now, the left-hand side, those are not the same, right? Squaring the sine versus squaring the subtraction is totally different. What we're going to do is we're going to take this bottom one, and that's a difference of 2 squares. So we're going to factor it. So we're going to make it, we're going to keep the top 1 minus sine x squared. I'm not multiplying that out because look at this. 1 minus sine x, 1 minus sine x. So if I distribute that, that's not going to work out. So I want to leave it factored. On the bottom, I want to factor that one. So the difference of 2 squares would be 1 minus sine x and 1 plus sine x. Then we can go ahead and cancel this one with one of these. Okay, and that will get us exactly what we want. So we'll have 1 minus sine x over 1 plus sine x on both sides. And then we've verified our identity because those are exactly the same. Okay, so there is number 4. Okay. All right, the last thing we want to do here in the lecture is I do want to show you how to show that something's not an identity. So if it turns out not to be true. Now, when it's an identity, we want it to work for any value of x, all values of x. So that means that we want to keep it generic. We want to simplify whatever's there, okay? Now, if I were to do the same thing here, I'm going to get a statement that's actually going to work, right? So it's going to be an identity from up above. But in order to show something is not an identity, you've got to find a value for x that when you plug it in, it's not true, okay? Now, if we think about what's going on here, this cotangent over here is going to be, does not have a square or anything on it, but it's equal to the square root. And there's no plus or minus there, which means that if the cotangent happens to be negative, what's on the right is only going to be positive. So that's going to give me an answer that doesn't match. And that's what I'm looking for. I'm looking for something that doesn't give me the same thing on both sides. So I want what's on the left to be negative, what's on the right to be positive, and then it'll be a mismatch. To make the cotangent negative, I need to know where is cotangent negative. So what value of x do I pick? Well, I want to choose a value where cotangent is negative. So CAST is what's positive in each quadrant. So if I want cotangent to be negative, I want to avoid this I want to avoid this quadrant, not that one, okay, because everything's positive there, which means cotangent's positive. I'm also going to avoid the one with tangent because cotangent's partner is tangent, and so it's positive wherever tangent is positive. And tangent is also positive down here. That's what the T stands for. So if I want cotangent to be negative, I need to put it in either the S or the C. Doesn't matter which one you go with. I'm going to go with S. So I'm going to put my angle over here. It also doesn't matter what angle you pick in there. So I'm going to pick one that I'm familiar with, which would be 45. Okay. Now, if my reference angle is 45, then my X value coming from here is going to be 180 minus that. So that's going to be 135 degrees. Okay. So what I want to do is I want to try to plug in 135 and see if that will give me something that doesn't work. So I want to know, what is the cotangent of 135, and is that equal to the square root of the cosecant squared of 135 minus 1. Okay. Now you could grab a calculator and plug in and get these values, but I want to do it by hand. Okay, so the cotangent of 135, we already have our reference angle. So our reference angle is with this 45 degrees, and so we have our triangle. And when the 45, 45, 90, this side is 1, this side is 1, and this side is the square root of 2. Now, if I want the cotangent, that's the reciprocal of tangent. So we know that tangent is opposite over adjacent, which means that the cotangent is the adjacent side over the opposite. So if I'm my 45 degrees, I want the adjacent side, which is the bottom, so that's a 1, divided by the opposite, which is also a 1. So the value here is going to turn out to be 1. Now, I'm in a position where cotangent is negative, so I'm actually going to get negative 1. Right? We chose it so that would happen. So now I need to plug in cosecant of 135. Well, cosecant is tied to sine. So sine is the opposite over the hypotenuse. And so cosecant is the hypotenuse over the opposite. Okay. Now, in my 45, 45 triangle, the hypotenuse is the square root of 2, and the opposite side is 1. So I want square root of something squared minus 1. The cosine of 135 is the square root of 2 over 1, right? And is it positive or negative? Well, cosecant is paired up with sine, and I'm in quadrant where it's labeled S, so they're both going to be positive, so it's going to be positive square root of 2 over 1. Now, it's not going to matter because if I plug that in a negative and square it, it's going to give me something positive anyway. But let's see what happens now if we do the algebra. So on the left, I have negative 1. On the right, if you square the square root of 2 over 1, you just get 2 minus 1, and 2 minus 1 is 1. And the square root of 1 is 1. So these two, this does not work, right? This is not equal. So this does not work, which implies this is not an identity. So to show something's an identity, you have to do it in general, use algebra in general. And to show something's not an identity, you just have to find one value that doesn't work, okay?